Hello, Farah. Noel, you can see Kelvin. So, Kelvin, you managed to figure out where is the exam hall? Yeah, you have some seniors here to actually let me guess, help you out. The G2, okay? Yeah, G2 group cohorts. Yeah. So, okay. All right, so we continue our last part. Yeah, part 4, chapter 11, part 4. Sorry, Kelvin, our projector is faulty, so it's being fixed. Yeah, so we haven't have a replacement yet. For that one. Hmm? Sorry? Yeah, I think we 202 or something. Yeah. So it should be good thing if we have more with the air to circulate. Right. So yes, chapter 11, part 4, module 14, network automation. So I'm gonna continue with this. Record our meeting. Okay. So recording started. Kelvin can start. Can join the from there. Okay. Okay. So the topics under this chapter, this part 4 of the chapter, it's not this. Okay. This is from the part 3. Right. So actually, let me just very quickly should be automation, data formats, APIs, REST. Sorry for interrupting. Yeah. So, do you want just get back the tariff and some quick tariff? 如果你要那个 tariff 是你要跟住那个饼名字一起买，那个饼 Yeah, go ahead. Teacher, you want? I already ordered. Should be the delivery. You said Miss Pang already paid for me. Oh, yeah. Oh, I forgot already. Okay. Okay. Yeah, I was talking about the topics inside this part. We have the automation, data formats, APIs, REST, configuration management tools, IBM and Cisco DNS Center. Why is it IBM? It should be IB. Yeah, oh, all right. IBM, intent-based networking. I'm gonna just on my account. Right, so I've opened up my account. So these are the topics that we can look at, and there are few videos towards the end that maybe it would be nice to watch. Right, so let's start with automation. Right, so automation, basically, this automation is done by using computer programs and also um, some very high-tech piece of equipment or machinery, right? So here you can see self-serving checkouts at stores. Okay, that's one, right? So I'm not sure whether in KK got, right? But definitely in KL they have already lah. Okay, the one I saw in KL was in IKEA. IKEA they have a self-service serving checkouts over there, but the latest version, in fact, I think using RFID. Okay, so you're basically pushing your cart, right? Your cart at the supermarket, and whatever you want to purchase, you just place inside your cart. It will be detected, right, as you purchase it, right? As you go around and as you pass a certain threshold, that means you're going out of stores. Your card or your wallet will be charged accordingly. That means you don't have to go and see any cashier. You don't have to go through any checkout. You just basically pick those uh, goods that you want and then just bring them out. Okay, the system is clever enough to figure out what did you choose and automatically deduct from your wallet, right? And then it basically seems like as if you know you don't have to pay anything. But I think last time I saw that there's a store in downtown KK where this is I think Riverson Walk or something. Did any of you been there to try out? I think this was before pandemic. Not sure whether during pandemic until now the place is still open. Right? You go in, purchase, and then go out. Right? So these are the sort of automation that we are talking about. Of course, including autonomous cars and planes autopilot lah, right? We still need a pilot there. So, but there are some autonomous features of the plane. Sometimes I have to say that, right? At the moment, the it's not foolproof. The couple of planes that crashed at the time belonging to Boeing was because of this autonomous feature. Sensor malfunction due, and also um, some error in the programming caused the two planes, I think Indonesian and Ethiopian planes to crash, right? Okay, but in any case, this is the future, yeah, automation, right? So let me just see whether we have any video on automation. Right. Yeah. So I'm going to share this tab.
The internet. Once here, now it's suddenly everywhere, unleashing a world of opportunities. The Internet of Things. It's already here, in cars that drive themselves. Here, where gate sensors put fans in their seats faster. Here, bringing doctors and patients together virtually. Smart buildings are already reducing energy costs here. Drones use infrared imaging to detect crop failure here, while sensor-driven pumps conserve water here. Networked sensors and cameras let students in and keep trouble out here, while smart vending machines personalize the shopping experience here. The Internet of Things is cutting unscheduled downtime here. It's turning data into profits, streetlights into guardians, and mines into safer, more profitable production centers. Here, millions of containers can now be tracked in real time from a single location, while connected emergency vehicles turn the lights green here. And playgrounds are now safe places to play here. Welcome to a world of things, already making a world of difference, in so many ways, in so many places. Where will you take it next?
Sorry. All right, sorry. Example here, right? So this is Ministry of International Trade and Industry. Okay. So your ministry under the our government, and you can see under transforming industry forward um, effort, they have Industry 4.0, right? So let me just share this in our messaging so you guys can read it yourself. So you can see that even our government is heavily pushing this Industry 4.0. So what is it? Actually, is smart factory, right? Is the next evolution of the. It's not revolution, but evolution, because every time the industry, okay, have something new that tries to push the industry forward. Yeah. So here, industry means it can be manufacturing, it could be agriculture, and the 4.0 indicates that it's the fourth, um, fourth era already, lah, right? And when we talk about industry 4.0, let me just show you, right? So example here, talking about industry 4.0 is a smart factory, right? So you can imagine that there are already robots there in the factory beforehand, but the robots are dumb robots. Basically, it's there to replace human because the robot can work 24 hours without getting tired, right? But the additional focus on robotics in Industry 4.0 is that these robots are now smart, imbued with artificial intelligence, yeah? and is able to learn, right? So not only are there uh, just some kind of dumb robots that help us to replace workers, but it can also perform other things that last time need human to do, right? So these are all the technologies, okay, that is available right now that is uh, combining to provide, okay, the impetus for Industry 4.0. So AI, big data and computing, large computing power now, our improvement, our advancement in robotics, augmented reality, virtual reality, right? CAD, 3D printing, we know that already, right? Simulation, digital twin. The digital twin means you mirror exactly what you have in the real world into the digital world. So let's say I have a view of my factory. If I click on certain buttons on my view, right, inside my digital representation, the actual piece of machinery in the real world will respond accordingly, right? So that means I'm producing a digital twin of my real world machinery in my factory, for example. So that's what we mean by digital twin. And another technology, right? Recent technology that is enabling all this is that high-speed bandwidth, right? And provisioned by 5G, right? And then ubiquitous sensing here means sensors, right? For whatever kind of sensors we have, ubiquitous simply means it's all over us, right? So basically it's IoT, Internet of Things, right? So these are part and parcel of when we think about automation, okay, smart factory, right? Driverless cars. Okay, so you can see Industry 4.0 actually encapsulate all this, right? Machines, that means robots, yeah, can work 24 hours a day without breaks, which results in greater output. Machines provide more uniform product means more towards the specification without diversion from it. It means we're not going to have a lot of product that is inconsistent, right? More precise, right? But additional things introduced recently is that we have AI now controlling the machines rather than just the machine doing over the same task. Okay, right. So automation allows collection of vast amount of data, and when we talk about vast amount of data, we can also mean big data, right? That means a huge amount of data. Okay, because of now our storage media become cheap, right? And it's also capable to store more and more, right? And also to transfer data across the internet is now easier than ever because of the fast bandwidth. Okay, so quickly analyze to provide information is now quickly being done by machine learning algorithm, right? So can provide insight into those big data better than any human can, simply because the amount of data, right? Amount of data involved, right? And robots can be used in dangerous conditions that's suitable for human, for example, mining, firefighting, cleaning up industrial accident. I can tell you about Fukushima in Japan and also Chernobyl. It is highly radioactive, and it's highly dangerous to humans. Okay, high level dosage of radiation can kill a person or cause cancer, right? So of course we don't want to waste humans to go and do the task inside the radiation area. So we send in robots. Robots is all right. They're not affected, right? They don't have DNA that can be knocked off, right, by the the frequency of the radiation. So smart devices can alter the behavior. That means they adapt right? They adapt because of their sensors and actuators. Okay, they are able to have a feedback loop, right? So that means they can adapt to work in such a way that they actually reduce the energy consumption, right? They can make medical diagnosis, right? We have expert system to be in place of expert medical professional. We can also have vision system that can actually look at scan medical image, yeah, right, and to highlight anomalies in the image so that the expert have a fewer number of images uh, curated for him or her to have a look, right? So can make medical diagnosis, also can improve automobile driving safety. Nowadays, even Malaysian cars have this, right? Have all the features for checking out of lane driving. We know that even Perodua also, and not necessarily the expensive options, also already have some kind of feature that helps us to improve our driving on the roads. Okay, so basically that is the trend, right? The trend. So increase in automation in our life, and it's going to be more and more, right? So thinking devices simply means AI software or machine learning software. Um, AI is the like for example the main field, and then under AI you have machine learning. Machine learning algorithms that how to can learn, right? Can learn um, to do certain things, right? So nowadays, devices are included with smart technology. Okay, basically smart technology is AI lah, artificial intelligence, right? For example, if I have a camera. If I take a picture, right, it will wait until uh, it detects, the face has a smile before taking the picture, for example, right? So it can, that means the software is able to detect or recognize human expression smiling. Okay. All right. So um, okay. So here many I can just read down, right? So because this one says peak demand or complex a self-driving car, this example, whenever device like the course of action based on outside piece of information means a sensor brings in information about the environment, right? Okay, and then based on that, the software running inside the device can make decision based on the input from the sensor. Okay, so we call that can respond to stimuli smart device, right? So many devices now are able to do that. Therefore, we always see the keyword smart as part of their names, right? That means the device can adapt, right, and change its behavior based on what it perceives from the environment. Means it knows how to behave depending on sensor values. Okay, so the behavior is actually an expression of its programming, right? So we always say behavior because when we look at human beings, how they act is what is their behavior. So behavior in the sense given to the device is the programming of that device. Means how does the device act? Okay, so the device act a certain way or a different way depending on the sensor values, the whatever its sensor is, whatever it encounters. For example, let's say take an aircon, right? If the sensor feels that, oh, the temperature now is very cool because been running for at a very high, very fan is running at high speed and temperature very low to cool down the room. But now it detects with its sensor, which is a temperature sensor, yeah, that is now the room is cold, right? So co means what, right? So it learns from the human, what the human feels that it's cold, right? So it will alter itself, its operation. The behavior changes. For example, it will increase the temperature of the aircon up by maybe 5 degrees, right? And lowers down the fan to medium setting. So this is a behavior. Okay, so it changes the behavior based on the values it has from the sensor, which is its temperature sensor. Right? In order for the device to think, they need to be programmed using network automation tools. Right? Okay, so I think that one is straightforward. Let's move on to the second section, which is data format. All right, so data format, I think you guys learning about web, uh, web application. Okay, you guys will have encountered this data format: HTML, XML, JSON, and YAML. Right. So what I'm going to do is right now show you the video.
In web programming, data formats are simply a way to store and exchange data in a structured format. HTML, or hypertext markup language, is a way of structuring data for software to understand. In this case, you have the web page in HTML, and the web browser or software is able to understand the markup language and then present the data with the proper styling. The data formats we'll be looking at all have similar characteristics. The data is structured and meant to be easily processed by computer software, as well as being readable to the human eye. The data has a special syntax. The data can represent objects, similar to JavaScript objects or programmable objects. The data objects are represented using key value notation or name value notation. Data objects' values can be strings, numbers, booleans. An object can contain another object or a list and array. The data is meant to be serialized or converted to a format that allows sharing or storage in a form that allows recovery of its original structure. Data serialization refers to converting structured data to a format that allows sharing or storage of the data in a form that allows recovery of its original structure. In this case, you have a JavaScript object that is being stringified or turned into a string of data for being sent over the internet. At its destination, this string can be parsed and turned back into an object. The common data formats used in network automation are XML, JSON, and YAML. XML was designed for the internet and looks a lot like HTML. It's generally hard to read as it was designed to carry data, not display it. It uses tags to structure the data where the value is between the key tags. The tags can have attributes. Whitespace is ignored. Sitemaps often use XML files, and configuration files also often use XML files. JSON is simpler and more readable than XML. It uses colon-separated key value pairs, where the key is surrounded by quotes. JSON objects are separated by commas and bounded by curly braces. The objects can support strings, numbers, booleans, arrays, and other objects. Objects are surrounded by curly braces and arrays are surrounded by brackets. Whitespace is ignored, and JSON, like XML, is supported by web browsers. YAML is simpler and more readable than both XML and JSON. It uses colon-separated key value pairs, where no quotes are necessary or commas. Whitespace defines the structure of a YAML file in comparison to XML and JSON, and indentation is important for defining the objects. YAML will try to assume the type of data or data type. YAML is newer than XML and JSON and gaining in popularity, especially with network programmability. Let's look at how the data is organized in XML. You have the data objects with the key IP address and the value pair 192.168.0.100. So this is a key value data object, the net mask and the gateway, all data objects with key value pairs. These three objects are part of the gigabit Ethernet 0 object. The gigabit Ethernet 0 object's part of the interface object, and the interface object's part of the network settings object. The similar structure is seen in JSON, where the IP address, netmask, and gateway data objects are part of the gigabit Ethernet 0 object, which is part of the interface and the network settings. In this case, the interface also has an array for the listing of additional interfaces. Notice how the structure here is defined by the curly brace and the commas. And with YAML, this is the simplest format. The structure is defined by the indentation of the white space. IP address, netmask, and gateway are all indented one space within gigabit Ethernet 0, making these three data objects part of the gigabit Ethernet 0 object. The gigabit Ethernet 0 is an item in a list because of the dash, and this is all part of the interface object, which is part of the network settings object defined by the indentation.
On mute. Just repeat. As I was saying, if you're taking web programming or web application courses, you will know this format. All this format is a way to is a structured way, okay, to contain any data. HTML we know is a way to mark up the content, right? To provide enhancement to the content, whereby the content is not affected, right? But the interpretation will be interpreted by the browser. The three down there, XML, JSON, YAML, grew up as a way to exchange data, but in a format that is text mode, first of all, and it's not binary mode, so it's text mode, but it's highly structured in a way that you can actually have a name value pair, right? So that we can say that, right, this particular data is belong to this name, right? Name and then the value. Okay, so in a sense, it matches up with how we look at data. Okay, as an example from database. Now, database as a whole, right, is stored in a sometimes a proprietary manner, right? And if you retrieve database, usually from the database to the web server, and then the web server translate that information in object format and then present it into the HTML, and then this HTML will then be downloaded by the client browser and displayed at the user's screen, browser screen. But what if I want to get the information, right, without being converted into HTML? I just want the information, right? It could be from the database, it could be from some other source, but I want you to transfer the data to me. So this is where this kind of data formats very useful, right? And first, they are not proprietary, they are not binary, they are just simply text string. So XML, JSON, and YAML, the only difference between them is the way the syntax of how they structure the data. Okay, so you can see just now XML has a pair exactly like HTML in order to indicate the value and the name of the value of the field. JSON basically uses curly braces and square brackets to say that this is an object and this is an array. And again, the name value pair is separated by colon. YAML is very similar to Python. They use the indentation to indicate this hierarchy. So whatever it is, in in web application where you have REST. Okay, so let me just bring up to you what is REST. REST services. Okay. Okay, so I'll just give you Wikipedia as the easiest, right? Okay, so this is another different way of presenting the data that is provided as a service from the web server or web application. Like you can see, right? So access resource by use of JSON XML to transmit data, right? That means I don't want you to embed the data into a web page and then I see the web page. I want you to give me the data. So in this kind of scenario, I want you to give me the data. That means I'm the client. Instead of me looking at the data via a web browser, I want you to give me the data. So in that case, you might want to use representative step transfer or REST, whereby you can either use JSON or XML, right? YAML is not used here, but you can find other example, a similar example with YAML, right? And so you receive the data. Okay, you interpret. It's easy because you can get XML JSON parser to retrieve the data, and then up to you when you receive it at your site, at the client side, you can then maybe transfer the data into your own application or whatever you want to do with the data. Right? So instead of like it's being placed in a HTML, right? HTML. So let me show you a three-tier web application architecture. So I was showing you this, right? So typically, three-tier web application architecture looks like this, right? You get the data from database server. It gets sent to your web server and application server where your web app is, right? But the thing is, those data from the server will be placed as part of your HTML. Think about web app, yeah? And then that data is already part of the HTML. Sometimes your client may not want that, may not want to view it as part of the HTML that you create from your web app. Maybe the client wants the data itself. So how are you going to transfer, right? So in one of the most popular way is to use REST and then use either JSON or XML format to transfer the data. Right? So XML. So let's see REST XML sample. Okay, so let's see one of the example how full of the data, not the programming example. Let's see here. So this is XML. So you can see that it's actually like if you know how to read HTML, you will know how to read XML. But there are no fixed protocol to indicate what should you put, right? So it depends on you, up to you. You say bookstore. It means inside bookstore you have many books. So you can imagine bookstore is a table. Okay, and book, each of these book, right, with its title, author, year, price, and so on, is your record. So you can imagine how you can translate from a book table into this kind of XML. Then you transfer this XML to the client. Okay, rather than and then this one, because it's XML, right? You can then, your client can then process this as the client wants, retrieve the content inside, rather than having to view it and cannot do anything with the data, because then you have to pass the HTML instead, right? So I can let me just show you that actually there's so many libraries. I'll just share with you this XML parser, right? So if you search for XML parser in GitHub, you can see many examples where you can then use it as a library to actually pass through the XML and read the content, right? All right. So this is the data format, and as an example, just now from the audio, it shows you that they are thinking about. Remember the previous part 3, where we separate the concerns of data and controller, right? So some of the configuration might be sent from the controller to the data. So in what kind of format do we send them? So example just now from the video is we use XML, right? XML to contain that data, right? So XML is much better way to as a container for your data compared to HTML. Okay. Right. So data format rules, we talked about it earlier on. How do we? This one, I think this is JSON, right? Using curly braces and square. It's just a way for you to indicate that what is the message, success, timestamp, and this value. So the name and value, okay, right? So the comparison between three different, right? So JSON is basically like this. So even Windows also use JSON in terms of the way they right. So XML, I gave you example just now. Okay, you you basically place your data within a pair of um, the node name, message, success message. Whereas for JSON, simply name and then value. Okay. YAML is even simpler. You don't even have the curly braces to act as delimiter. Okay. One problem with for me with YAML is that you have to be careful about the indentation because that's the way that they can tell the hierarchy of your data. Right? Whereas here, white space is not actually considered as crucial because we depend on the curly braces as an object. Okay, it means since these two are in curly braces for ISS position, then we know that these two value is belonging to the ISS position, right? We know that because of this syntax, right? For this one, then this one has a problem with it. You can see the indentation is wrong, so this will give a problem. Okay. So dependent whether you want to use JSON or XML or YAML, but most people go for XML or JSON, okay? Especially in the web application or web services, right? Right. So JSON again, the parser. When you say parse, right, means you go through the JSON file, okay, and you understand the JSON format. So that means you can then retrieve the name and the value inside, right? And then you can then retrieve it and then you can deal with it as you want, okay? So a lot of times, we talk about serialization. Serialization, actually, if I give Java as an example, to serialize simply means that you convert the binary format, which is the object, okay? Just the way we keep data inside, for example, our chosen programming language, let's say Java, right? It's actually binary. Even though you say it's string, but it's actually object, right? So object actually represented as binary inside our memory. So in order to unroll that and store the content of that instance of the class, the object, you have to serialize it, right? Serialize it, then you can convert it to string, and then you can serialize it to file, for example, right? Or serialize it and then put it into a format like XML, and then you can then send it off through the network, right? And then when you reach the other side, you can then deserialize it, turn it back into object format. Then you can then use your program to do what you want with that data. Okay? So that means XML and JSON is just a container during transport. One thing, another very useful use for them is actually when you have two incompatible systems and they need to do data exchange, right? So because they are two separate systems, their default data format is not compatible to each other. So in order to transfer data from one system to another system and exchange data, you need to basically have a standard format in between so that they both can understand. So XML is usually a way to bridge two separate systems, right? In terms of exchange of data. Okay, right? Right. So again, here representation of JSON, right? If how would you say this? Describe or store this for transport, right? So it's very, very highly structured, JSON, XML, and YAML. Okay, so we can give an interface. On that interface, you have the interface name and the description of it, and then is it enabled means it's up, right? Up here can be represented by enabled true. Down will be false. Then what kind of internet address it has is IPv4, right? And then what is the address given here? The /24 can be represented by the actual net mask or subnet mask, right? So you can see a translation of this, okay, into something that is standard. This is because this is a standard JSON data format. It's one of the standard. So if the receiving application understand JSON format, then they can then understand this data. Okay, compare that with this. The output is this, right? And then there's no standard now, basically, right? So the receiver might not understand. Oh, what data are you showing me? Okay, so we convert this kind of info. It's full of information here into something that is can be understood because it's following certain standard. In this case, JSON, right? And then very easy now. Once you this create this format using JSON, right? That means you don't change lah. Once you identify the name of the interface, you get a description, enable or true or false, and so on. Then you stick to this format. Then the other end, the other process will be able to understand this, right? And also understand the message being sent, right? So here in this slide here is just talking about the JSON syntax, right? Okay, what is a valid JSON syntax? Okay. So again, see, here is still talking about the JSON syntax, right? And how it looks like. Okay. Okay, so you can imagine that this object addresses has an array. Inside the array, there's 3 elements, right? First element, second element, third element. Okay, so this is quite easy for human readable, quite easy for us to understand, but it's also machine readable as long as the other application understand JSON syntax. Okay, it's able to pass through JSON file. Right. So the next one we're going to look at YAML. Right. So it's like JSON, but is simpler. Simpler in the sense that it doesn't have all these curly and square brackets. And it uses, like Python, it uses indentation. That means what space are in front to indicate hierarchy. Okay. So you can see on the left is JSON, on the right is representation in YAML format. Right. So the difference here you can see is the indentation. Okay. The indentation indicates what? The hierarchy of the information within this data format. Okay, so the mode that means the data with indentation belongs to the previous name. So that means this IP address all belong to address, right? So if they are the same level, means same number of spaces for indentation, means they are peers, they are in the same level. Okay. Right. Finally, we look at XML. XML is basically very similar to HTML, but the tags itself are customizable. That means you can decide. The tag is the name, and the value inside the tags, the pair of tags are the data value. Okay, so it's quite popular. Apart from JSON, XML is quite popular. So you can see the example of this of how XML encodes based on the info previously. Okay, you can compare between this and the YAML and the JSON, right? So we still have, it's just that we use the pair to indicate that everything inside here belongs to the interface, right? Now, I have to say that the indentation here is just for ease of reading. It's got nothing to do with the syntax. It will be as recognize so valid XML even without the indent. Only YAML actually, with the indent, is very important to have the indentation correctly. With XML, it's not, but this one is just easier to read. So in any of the text editor that recognize XML, you can beautify the XML by automatically by using the tool inside the text editor to perform this indentation to make it easy for humans to read, right? So it's just a tag with the starting tag and the ending tag, and then the value in the middle, right? So this is the format for XML. Okay, right. Next, we talk about APIs. API stands for Application Programming Interface. So a lot of times when people come to study networking, they may not have the industry, like in the industry, professional, they may not have background in programming. Okay, they may have, but maybe just a little bit. Okay, so for you guys have an advantage when you talk about this, right? Because when you talk about API, you know API is a way to access certain feature functions, right? So you usually, as a programmer, how you access these features and function is via published APIs, Application Programming Interface. You interface with what? The library that has the implemented code for these functions and features that you want to use in your own program, right? So for you guys, because you used this before, like for example in Java, you can just import the library, and the the API, the use of the API means you basically import that the library and then all sort of APIs available. And using the correct IDE or editor, okay, with IntelliSense, very easily, you don't even have to memorize, okay? Um, the editor will provide some hints to you as you're typing your program, right? What are the available APIs? Okay, so let us have a look at the video for APIs. This video is
This video is a quick introduction to APIs, or Application Programming Interfaces. If you're interested in getting some more information, I recommend Hank Preston's video series, Network Programming Basics. You'll find it at Cisco NetDev. An API is a way for two pieces of software to talk with each other, like a middleman that helps to send and receive information. With APIs, someone else has already done all of the hard programming. You just need to know the API calls to get the information. We are using APIs all the time. Every time we're searching for restaurants on Yelp, getting directions on Google Maps, or watching videos on YouTube, following a Twitter feed, or generating random quotes for our emails, or looking at satellite-generated images of space. This image is an example of the astronomy picture of the day from NASA. NASA has its own API that you can call to get an astronomy picture every day. The importance of APIs. APIs are very important in programmable software-defined networks. APIs are changing the traditional approach to the user interface. And APIs are used to communicate between services, network devices, and monitoring and management software. Popular APIs are SOAP, which is a mature API standard designed by Microsoft and used to build internet web services. It uses HTTP and XML. REST, which is an API framework that's simpler and more flexible to use than SOAP. It uses HTTP and supports JSON along with XML. NetConf, which was designed to replace SNMP as a programmatic interface between management programs and network devices. It uses SSH and XML. And RESTconf, which is built off of REST and is a REST-like API interface to the network. It supports XML and JSON, defines transport and communication, and is coupled to Yang for data, like NetConf. Let's take a look at an API in action. If you're interested in getting the astronomy picture of the day, you can go to nasa.gov and search for APOD. Here you can see on the Getting Started page, it tells you exactly what to do. You're going to need an API key, but you can also use their demo key, and it basically shows you the step-by-step process for getting it started. This was yesterday's image. To execute an API call, you can use a browser. In Firefox here, I have an example of using the nasa.gov API, and I've put in my API call right into the URL. That's because this API framework uses REST, or representational state transfer, which uses HTTP requests. And this is an example of a GET request. It uses the REST API to get information from nasa.gov regarding APOD, or the astronomy picture of the day. You can see that the API key is just the demo key that anybody can use. This returns all of this information related to the astronomy picture of the day. You can also use Postman. Here in Postman, I'm using REST once again. You can see here, there's the GET request. Here is the URL. You can see there's other choices besides GET. You could use POST, PUT, delete if you're requesting data or uploading data or sending data. You can see here, there goes the API key, the demo key, and this is what was returned. Now, if you want to use an API, an REST API framework into a program, you can see in this example, I'm using the web browser to write and execute code right from the browser. On the left-hand side, I've created a HTML page with JavaScript. My GET request, you can see right here, and this is the API being used. This is the JavaScript that's going to request the picture of the day from nasa.gov. All I have to do is click this button to run my code, and the results will show up in the browser on the right.
Okay, so I just pause here because I just want to highlight the difference between using something like REST and just simply getting the picture. Because the thing is, um, if you don't have a feature like this REST kind of service or SOAP from Microsoft, what you get is NASA idea of a web page that shows you the image, right? That's it, because they embed it into the HTML. That's the traditional way you look at or you create a web page, right? Web application, right? So I want you to consider later when you, if any of you are doing your your project, I just suddenly, this is the perfect place I want to explain to you guys about web services. So web services, just now you see the example, they send to you either in JSON or XML, then you can pass. They actually send to you the data in structured format. Then it's up to you, and it could be a web client here, right? Okay, passing through those data and displaying it, and then you have a control how it looks like, all right? Or it could be another application, right? It could be another application that is asking for the data, and then the application can then do what it wants with that data, all right? So this is the power of web services, right? That means you will decide what you want to do with the data, right? Rather than having the web application, okay, to display it to you with the fixed format. Right? So let me continue.
So let's click Run. And here's the new image of the day, the Elephant's Trunk Nebula in Cepheus.
Yes, the rest is a way to provide web services. Is actually separate from any language, right? So that means implementation. If you want to use Java, there's REST implementation in Java. Even in use PHP, there's REST implementation in PHP. So it's up to you, right? Because REST is actually an idea. It can be implemented in many server-side scripting or language, right? Um, it could be Python, right? If you like Python, it also can provide web services. Oh, but if you use SOAP as your web service provider, Microsoft, I think then you have to use .NET or C#, right? For Microsoft. So rather than REST, there's some people actually like Microsoft way, right? So just showing you now again back here, right? So that was an example of API. Okay, the API is a way for you to let the developer, the public, to access features or functionality that you want, you allow them to access. So a lot of times for programmers, this means libraries, right? Libraries. The APIs, as used in the NASA example, is actually an API to access their data, because the name of the image and the image itself is actually their data, NASA's data. So the API is a way for you to access those, right? Those data, right? So you can see here, API are basically libraries, and either you can use the library as in code, right? Code that can execute, or the library allows you to access data or services it provides. All right. So this is another example of API, right? So it says here the example is for booking airline reservation. Okay. Okay. So this is the first example. The first example here is a web application that typically the 3-tier application that we'll normally do. So imagine you can see here that is a web form, right? You enter the details here, then it goes to usually the web application will access the database, right? And then your web application retrieve those data from database and then simply format it themselves and show you onto the screen, right? And that is the typical way we use a web application, right? Okay. So the other way is accessing, right? The using the web service. Web service do not basically format the data when it gets to you. They just simply use a container to send to you, right? All right. So here you can see your favorite airline database, your direct access, it gives you the information. But sometimes, right, we have different airlines, A, B, C, and so on, and maybe their systems are all inconsistent with each other, meaning to say they are all using different format. Of course not, because different airline, different system. So let's say, imagine you have Malaysia Airlines and AirAsia and so on, right? So at the moment, what you can do is you can go to their website and they can just give you their own data, right? And but imagine a portal, right, where you can get information from both airlines, Malaysia Airlines and AirAsia at the same time. And I think we add the Malindo as well, so 3 airlines, right? So the thing is, Malaysia Airlines system and AirAsia system and Malindo Airline system are all different. So if you want to aggregate them, okay, display them at the same time to the user, it's quite difficult, right? But if they have web services, right, where you can request for the information and they give you the information only, just like the using XML or JSON, whatever, then your site, okay, that aggregates all this information together, understood all these standard format like XML or JSON or whatever, right? Then you can combine those data and display it, okay, in a form where you can then show the user in the same page. Okay, so the data from different airlines, right? So this is a typical example usage of web services, right? Okay, so talking about APIs, there are open APIs or public APIs. That means anybody can access it. There are also internal or private APIs, and there are partner APIs. A lot of these things is because of restriction. So if I give you one example of API, this one is right. This one for programmers. So I'll just show you, right? So what I want to show you here is if you want to access Google Map and to basically use Google Map platform, right? You need to get the key, API key. Once you have the key, if you get the free key, that means you're limited to how many calls at a time. But if you basically willing to pay, then you during deployment, during usage already, then you can purchase based on the pricing, how many times you can call the APIs. They actually charge you on how many calls in a day you're going to call their API, right? So you can see, you can even have distance metrics, travel. That means you can develop your own application, and then use Google Map platform, right, with their API, and you don't have to program it. You can see, you can set two location, find the travel time and distance, right? Elevation data, geocoding, and other things, right? You can see that, right? So these are examples of API that we are talking about, okay? Right? So is Google API open? Not really, because she says publicly available and can be used with no restriction, right? So yes, Google has a free key, but the free key is limited. Google API. Only when you pay, right, then you can get access to more features. All right. So and then we have internal or private. This one actually not available to public because this is basically in-house. Okay, in-house. This one is used by only by the authorized people or personnel. Usually the employees of the organization, right? And then partner APIs are only between business partners. Okay, so let's say you have a system and your supplier has a system. Okay, you as a manufacturer and your supplier also have a system. In order to ease, right, combination between your system and your supplier to ease the purchasing. For example, let's say you're manufacturing, right? You always order components or raw materials in order for you to basically produce your products, right? But you don't want like the old system where you manually create a in what you call purchase order, and then fax over or send over too slow, right? So maybe you want to connect your system, right? Connect your system. So to connect to each other's system, maybe use maybe APIs, right? So then it make it faster, right? And it's not available to everyone, just your selected partner, because it's your business partner, right? In the sense, we say business partner because you have a deal with your supplier. Okay, you supply, I become your like customer lah. I buy your components, I buy your raw materials for my factory. I manufacture these other products, right? To ease our system interacting with each other. So if I do a purchase order, right, I access your system using the API, then I can directly send a purchase order, right? Or if you want to access, maybe you want to deliver, I don't have to order from you. I give you, if you can straight away access my system via my API to see whether there's any of the raw materials going down beyond the reorder level. So if we reach reorder level, you automatically will send those raw materials to me. So my factory never run out. Okay. because I cannot have downtime. For example, this example where Pubmed APIs is actually very useful. All right. All right. So types of web services just now with yes. Sorry. Oh, share this time. All right. Right. Thank you. Thank you, Kevin. Right. So different types of web service APIs. Just now we saw already a simple object access protocol served by Microsoft. The open one is the REST, okay, representational state transfer, and then we have XML RPC and JSON RPC. Now, remote procedural call. This one, RPC is an old technology, right? Remote, that means a process can invoke another process remotely, means over the network. Okay, so these RPCs, whether you use XML or JSON, actually quite a while ago. In fact, even XML also as a data format is quite a while ago. It is actually the most popular use last time as a way to exchange data between incompatible systems. Because earlier on, a lot of companies, when they digitize their business process, they build silos. You know, system even within themselves, within their own organization, systems that are not meant to be compatible with each other. So, but basically, you have HR system that is only for HR, and then you have sales and marketing just for sales and marketing. So the thing is, they are not integrated. So the two systems are silos in the sense that they are independent from each other. Now the thing is, they realize, hey, hang on, would it be better if we connect all our systems together? So last time, not only within the organization itself, but between organizations, they start to want to share data, right? So they need a standard data transfer standard, right? So that's what XML provide lah, right? So you can see it's 1998, and then after that, at 2000, we have JSON XML in YAML, and then XML RPC also came into the market and JSON RPC as well, right? Right. So talking about REST, let's look at REST. REST is basically web services, a way to provide web services. Right? So I'm gonna share the video very quickly.
REST is a framework for creating web APIs built on HTTP and HTTPS. RESTconf is a REST-like API or protocol for managing and configuring network devices like routers and switches using HTTP. It uses Yang data modeling and netconf-defined data stores. So how do you execute a REST API request? Well, there's different ways you can do it. You could use your web browser using an HTTP request right from the address bar. You could use a command line tool like curl and do a curl command. You could use an application or program like Postman, or you could use a programming language like Python, JavaScript, Ruby, and many others. RESTful APIs use HTTP client-server request and response methods. The typical methods for HTTP and REST are POST, when you're going to create content onto the web server, GET, when you want to make a request for information from the API or from the web server, PUT, when you're sending data to the server, patch, when you're updating information or making a small change, or delete, when you're deleting a resource. The POST, GET, PUT, patch, and delete methods all follow what's called CRUD operations: create, read, update, and delete. Now, REST APIs use universal resource identifiers. It's similar to a URL, but identifies a specific resource. Let's take a look. And here you have the API server over here, It has the HTTP protocol named, and then the server location with the domain name. You have the resource that you're going to access. This would be the API information specific to that server. Then you have the query itself. This is your API query. And in this case, it's specifying the format, which is JSON, that there's going to be a key. Now this would say key equals, and then you'd have the public or guest key or the key that you requested from the server itself, and the parameters which filter your query. In this case, we're going to MapQuest, and we're interested in getting information from San Jose, California to Monterey, California, and we're trying to get directions from here to there, and that needs to be in the parameters for this API query. Let's take a look at an API query in action. Let's practice doing REST API calls using different tools. First off, using the web browser, I can do an HTTP GET API call by just pasting the URI into the address bar and hitting return. And with this API, all I need to do is provide the IP address and that I want JSON data returned, and then it gives me the location based on the IP address. The region is Texas, country US, and then the organization is Cisco Systems Incorporated. Now I can execute the same API call from the command line. I'll go to the command line and I'll use the curl tool, provide the same URI to call the API, and you can see that it returns the information. Now API calls, REST API calls can also be done programmatically using JavaScript. In this case, I have a tool where I can put my code into one window and it'll return out of the other. This is some JavaScript where I'm going to do a request, and I'm going to do my GET request. There is the API URI. I just hit run and it returns the information that I've asked for in the JavaScript. I can do the same thing using Python. Here is that same API call, but this time formatted in Python, where I execute the Python code in this web browser window, and then it's returned here. So I'll hit run, and you can see it's returned.
Yeah, we saw just now in the video, right, how we actually access REST using web browser, command line. Curl, I'm not sure whether we have curl in Windows. Let me just try. Okay, so there is a curl, right? I just tried it in command prompt. Mind you, this is Windows 11, right? So curl is for those of you who like to use command line interface, web browser with HTTP using the URI technique just now. Application is a specific application written to understand REST services, example Postman, and you can write your own code. You can write your own code. Just now we saw JavaScript and Python as an example, okay, to access the REST service. Okay, so the service is depending on the website, what the website allow you to access, right? But REST and RESTful API basically is two standards that as long as you understand how to access the services, the API, then it's okay, right? So a lot of times when you're doing, when you're writing a web application, you have to consider first, are you providing data also to people that or clients that just want the data, or you want them to just access your data through the interface that you provide for them? That means you embed them in HTML, or do you want to provide the data itself to your customers, your client, right? So So REST architecture is RESTful. Okay, if you you implement it using a client server architecture. It's stateless. No client data is stored on the server between requests. Right, the station set is stored on the client itself. It's cacheable. Right, clients can cache responses from the RESTful web server or web application in order to improve performance. Right, so here we think about the um, the HTTP methods that is used during the use of RESTful API. You have posts. Really, we have posts in get and put. Okay, and the patch and delete is the tool that is uncommonly used in HTTP. But for RESTful, right, because RESTful API use HTTP methods, is similar to create, read, update, and delete. Or this is CRUD, right? It means create basically if you compare them to database. Okay, I believe you understand the database better. I think you know create is insert, read is query, update is modify, and delete is delete, right? Okay, so if you're doing a query using HTTP, basically, just now we saw in the video a URI or Universal Resource Identifier, right? So you have the domain name where the API resides, and then the API name itself, and then after that the query through that API in order to get the service or the data, right? All right. So you can see here. Um, what we talk about. But here is actually the typical way you access a resource. Okay. Now, but here, in here is more clear, right? You can see that here is the domain name as usual, the URL, right? So in this case, our API server is there. Okay, it's very similar to the example I gave you guys, the Google Map. So this one is MapQuest, yeah. And then after that is the API itself, which API you want to get. So resource, right? Here is the API, and then the query to get from that resource. Okay, so you include what format if the API provide different format. Okay, in this case, we want JSON, you can put JSON, even XML, maybe they can produce XML as well. And mostly the resources need keys. Okay, here the map quest you need key, and just now I show you the Google Map also need key, right? Need key to use it. So different key for different access. Okay, usually lah, right? If it's a public one where it's free, then what a key is a key allow you to access the services. Maybe you don't have to pay, but a lot of services, especially map services, they make money from you as a developer. You may want to provide some customized service to your client, right? But of course, it's very expensive for you to create your own mapping map database. So you make use of the available ones. Of course, they're going to charge you, right? So depending if you purchase a certain key that allows you maybe how many calls. Right. So let me just give an example. Right. So for this one, you can see here pricing. Right. So 200. That's a lot, actually. $200 for usage every month for no charge. And then that's to 28,500 networks per month for no charge. Pay only for your use, right? So as you increase beyond 500,000 requests, that means you must be making a lot of money, because if your client is 500,000, right? Then you have to contact sales already. That means contact Google sales. Let's say you plan that about 50,000 people are going to make use of your web application, that you customize the use of Google Map, right? 50,000 users in a month, that's how much you pay Google. 100, so that means what, in Malaysia you get about 400, well, about slightly less than 500 ringgit lah. All right. So, and then there are pricing for different dynamic maps. This is static map, huh? Dynamic map, different pricing, right? Okay, so but they do also have free use, okay, free usage, but you keep it within a certain cost lah, because you don't give it to public yet. Then you only use it for testing. So that means you must be careful how many times you call the API. Okay, right? So the free version, right? Okay. So, and once you deploy, then maybe you are making money. So that means you want to provide to more customers, your own customers. So you also have to pay Google lah, right? So you can see a lot of products for Google Map. Okay.
So
Yeah.
is REST and RESTful, is it two different things?
Yes. I think RESTful. Hang on, let me just go back. Where is it? Right. So REST, actually REST is architecture, right? So, and then RESTful is a way to describe the REST architecture, right? So if there are some this REST architecture that you're implementing, right, conforms to these features, then it is, in addition that it is a REST architecture, it is a RESTful architecture if these three things are found inside your implementation. You get it?
Oh, okay.
Yeah. So without these three features, right, then yes, it is a REST architecture, but cannot call it RESTful. Okay. In order to be called RESTful, then your REST architecture implements these three. Provide these three. Okay.
Okay.
So let's continue. Oh yeah, let's talk about the key already. Just now I talked about key in terms of Google Map, right? So if you want to use Google Map, right, sometimes maybe you have a feature in your application, then you will show, oh, okay, so one of the application that my students ever done is if they want to, they create a schedule for students. Student have a schedule, so depending on the student, they say, I want study more. Okay, so more study allocation rather than exercise. Or they say, I want to lose weight, I want to exercise a lot. So the program can put more exercise slots. So exercise slots, then maybe they want to play badminton. So one of the things is you place a badminton slot, but then you have to find location, right? It could be at the campus, but it could be you find the nearest. Let's say the student stay where you can find the nearest badminton courts, right? Or you can find the best, the most rated badminton court rather than the nearest. So all this actually can be highlighted in the Google Map and then saved as part of the students' timetable schedule, right? So the thing is, how do you know where is the location? So that means if the student have to use Google Map API to basically find out where is this to search lah, right? The best or by rated by whatever. The thing is, yes, they are free for you to develop. right? And but again, once deploying, more people will use, then you have to consider paying money to Google, right? But then you of course offset it from what you earn from your own application, right? Because you provide a customized application based on Google Map, so you pay Google Map a certain amount price for the key, right? So and then that means developer key, trying out key, and also the deployed key, maybe all different lah, right? Based on the payment or pricing structure, right? So okay, so next let's look at configuration management tools, right? So configuration management tools, basically, let me just give you that one. Video going to see.
Network automation is pretty difficult when you're working with traditional network configuration tools like the Cisco IOS command line interface or CLI. Now, it has the ability to run some TCL or tickle scripts to automate some tasks, but generally it's considered very difficult. Network automation is also pretty difficult using SNMP or Simple Network Management Protocol. Although you have the ability to do remote network configurations, and it's excellent for monitoring the network, to push configurations to end devices and work with SNMP is generally considered to be labor intensive and difficult. Network automation today is developing rapidly thanks to networks moving to the cloud and the advent of virtualization. Today we have RESTful APIs and configuration management tools that can help to automate network configuration and other network tasks. Configuration management tools like Ansible, Puppet, Chef, and SaltStack. These configuration management tools typically use Python or Ruby. Ansible uses Python and YAML, whereas Puppet and Chef use Ruby and SaltStack uses Python. These management tools use recipes to script changes and automate changes over the network. Ansible uses playbooks, Puppet uses manifests, Chef uses cookbooks, and SaltStack uses pillars. This is an example of an Ansible playbook that I got from DevNet at developer.cisco.com. You can see that it has plays. Here we can see two plays. One, we're going to report host name and operating system details, and the second play, report network details of servers. The hosts are set up in the host file, and those define the actual IP address or domain names of the devices. For tasks, we have on the first play two tasks: get the host name from the server and then get the operating system. In the second play, we have three tasks. We want to find out what the default IPv4 interface is. We want to retrieve the network routes using a netstack command. We're going to put that information into a variable and then show that information with the network routes installed. To see the results of these tasks, we're going to use the debug modules, and modules can also use parameters. In this case, we're going to be using the message parameters. Lastly, we have the variables. The variables are surrounded by double curly braces. Now you can retrieve variables that are built in. These are facts within the system. Or you could set your own variables. In this case, we're registering a variable.
I just want to say something. Notice, although it's saying Ansible playbook here, you guys, please note the structure of the what you see on the screen. Do you recognize it? YAML, right?
YAML, yeah.
Yeah. So that's why we looked at XML, JSON, and YAML earlier on, right? Because of this, because when you are when you want to here you say configuration, right? when you want to send something, a value, command, or whatever, a highly structured way is to use any of this, whether YAML, XML, or JSON, right? And they are transferable through the network, right? And then API is a way for you, if you using multiple methods just now, yeah, to use RESTful technology to basically access services. And all this, why we talk about all this? Because this is the implementation that is considered when we want to do a software-defined networks. Earlier on, we talked about software-defined networks. This is all the technology available and is proposed to be used for doing software-defined network, right? It's not the video complaint about SNMP, although it's good, yeah, SNMP and Clean is good. But when you want to do more automation, when you want to do software-defined network, which is separating the control from the data flow itself, right? Then using Clean and SNMP is actually because they are not uh, useful for that kind of task, right? It becomes very difficult. Remember, for every switch, you need to go in and do your clean. Type in, isn't it? Very tedious. So with software-defined network, what you want to do is, again, like the wireless LAN controller with the lightweight AP, that idea where you have a central location where you can say, oh, this, for that switch, for that switch, for that switch, for that router, for that router. Rather than right now, think back to your SBA. If you have two switches, you have to go and configure two switches. That means in the first place, you have to have the architecture of your network, or what I'm going to do, right? The policy. Then I go into switch this, switch that, go to that router, go to the router for each individual device. You have to do something, right? Okay. This is very tedious, right? Even for you guys, although you're practicing and it's a small network, it's already tedious. Imagine if you are in an enterprise where you have lots of switch, lots of, okay? So actually network administrators and network engineers, they feel the pain already. Okay, they are asking, is there a better way to do networking? Right, so this, what we are looking here for this part is all the current technology that used for other things also can be used for networking, right? All the things we talk about, the beauty of SDN, right? So let me continue with the video first.
Called routes right here. And then we're going to use that variable in the message parameter in the debug module with a message parameter. We'll call that route variable. Let's take a look at this in action. I'm using CentOS 7 as my developer workstation. I'm going to cat out the example1.yaml file and take a look at our playbook. This is the same playbook we looked at in the slide deck. I'll clear the screen, and then I'm going to run the command ansible-playbook, put in the -user parameter for my username developer, and I'm going to run example1.yaml. And this should use Ansible to connect over to the DevNet sandbox and connect into the DevOps computer that I want to configure using my Ansible playbook. Okay, you can see that the play is running. Report host name and operating system details. Task 1, it's gathering the facts. All right, task 1, get the host name from the server. There it is, message devbox. And task 2, operating system. And there's the message returned, CentOS. Now for the second play in the playbook, report network details of servers. Okay, the default IPv4 interface and the message returned, there it is, ENS 160. The next task is to retrieve the network routes. Okay, we got a response. Looks like this playbook worked perfectly. You can see the reply back right here. These are the network routes installed. You can see it ran the netstat command with a argument of -rn for the route and the numbers. And you can see there is the routing table on the device.
Was the example, one example of how to use and simple playbook actually is implementation, yeah, and it uses the the technologies that we look at. It uses JSON, it uses the RESTful way of transferring all those data, right? So that video already show us some of the capabilities using the technology that we talk about, right? So here, the difficulty, I interrupt you guys watching the video just now to show you the difficulty of doing not only for play is configuring your network devices. For SNMP, basically is right now is used to gather information, right, for monitoring. So if you know what's the status of each of your devices, right? But the reverse is very difficult. You can't tell SNMP because it's simple network monitoring protocol. It's to monitor, not to place configuration into the device. So SNMP, well, you can't do that, right? Right? So the thing is, this is what we want. See, this is the pain point of all network administrators. Configuration. What do you guys? I want your feedback. How did you feel? Right? Even with one device, you already feel a little bit of pain, right? Configuring. So this is what they want. This is the ultimate thing they want to automate configuration. Okay, and this is the emerging technology. This is the future of networking. This is where they want to end up with, right? Okay, so that's what we call network automation. This is the holy grail, right? So you can see protocols and technologies that we have looked already. Okay, basically Ansible is product, right? Puppet is a product as well. REST is architecture. These two are data formatting for transfer of data, and then Python basically is a language. It's a scripting. I think it's a proper language, not scripting language, right? All these are combination is make use now to provide the network automation. So SDN, software defined network, is I believe the target, the target for automating a lot of this configuration. How nice if you can specify what you want, right? And software tools do the configuration for you, right? That will be the dream of any network engineer, because I can set the specification, I can back up my specification, I can just load my specification, what I want. In terms, I'm not talking about in detail knowing about commands to make it basically configure my switch or my network. I want policies, I want a very user-friendly user interface. Okay, I can specify what I want for my network, and the tools automate configuration for me, configure for me, right? So and here, this is the thing they want. Scale across thousands of devices. This is the problem. This is the problem. When you are dealing with enterprise networks, okay, you're dealing with thousands of devices. I'm not sure if I can. To be honest, I have to check how do they do it, right? At the moment, without those kind of tools, automation tools, right? Like Ansible, Puppet, Chef, SourceTech. I don't think you can, right? Okay, so these are comparison between the tools that we have right now. Python, YAML, Ruby, Python, agentless for Ansible, agent-based for Chef, and so on, right? So what is created by the tool? Chef is cookbook, Puppet is manifest, SourceStack is pillar, playbook. These are basically a way for you. You can tell the result like cookbook, right? It's a recipe basically, recipe to do certain things. Okay, so then that will be used in order to do the task. It's not your sole playbook. Playbook also is a task oriented, right? It's not the task was to get information, right? So the video was showing you how using YAML to store as a container for what you want. That means the instruction, what you want to retrieve, right? Okay, and it actually delivers, right? Delivers for you. The service is RESTful service. You have an API. You call it, send that to that and to get it, and the server basically replies. Right. So I think the final bit here is about IBM and Cisco DNS method, right? So intent-based networking. So you learn many tools and software that can help you automate your network. And intent-based networking, IBM and Cisco neural network architecture can help you bring it all together to create an automated network. All right. So play the video. All right. So let's play the video. The video by video by Apostle Paulus and Anon Oswald. So okay, I think they know it better than me. In fact, this right here, this one, right? So there are a lot of videos here, right? So that's one of the video. Again, here another video. We're not gonna play all of them. I let you guys to play those videos. I just want to play this one, right, to end our session.
So Anand and I are going to describe how intent-based networking works and how AI comes into play. So the four key areas. And the first, at the bottom, we have the infrastructure, which is the switches, the wireless APs, the routers, and so forth. On top is the intent. This is what the user wants to do. We take this intent, and then what we do is we translate it. And we basically translate the intent, what we want to do, into the network and security policies which we want to apply in the infrastructure. These network and security policies then are activate this on the infrastructure.
And all these are done through open APIs, programmable models.
Exactly, something that Cisco is very focused on open-based, on standards and open APIs, and this is all done through open APIs. And then not only do you want to instantiate an intent on the infrastructure, you want to see, is it actually working the way it should? Is the network delivering the service as desired? And that's what's called assurance. So the goal of assurance is to assure that the network is doing what's intended. Now what's interesting here is that AI comes into play in all these different boxes. Once the intent has been activated on the network, we want to check, is the network operating as intended? And that's the goal of assurance. So what assurance does is it gathers a huge amounts of data and performs various analysis of data, behavioral analytics, and so forth to determine, is the network behaving as it should, or is there a problem? If there's a problem, where is the problem? What is the root cause of the problem, and how can we fix it? It then provides this feedback to the user, and the user then could say, hey, yes, I see that problem. I want to fix it as recommended. I'm going to instantiate that. It then gets instantiated in the infrastructure. And then we once again check to see if it works as intended. If it does, awesome. If not, we make additional changes. So we have this very powerful feedback loop here. And the AIs in all the different parts. And by having AI, having this feedback loop and having AI, this accelerates what we're doing, improves the agility, and overall, for the end customer, it improves the performance, reliability, and the security for them.
And this is also the layer where, in addition to doing baselining of all the data that we have, then we can now do anomaly detection, we can do now site comparisons, and then we can next go into predictability of what may happen sometime later in the future.
Yes, which is incredibly useful for our customers because before they didn't have any of those capabilities. So this is really, really very valuable, very, very exciting times. Manan, myself, and many thousands of people spent about 5 years building this. So the reason it's so simple is because we spent about 5 years building it, and we're continuing to invest to build more and more capabilities into the intent-based networking.
Is that if you want to build something simple, because you want to make it simple for the user, right? So that means the user, basically, maybe the network engineer is the user, then it's going to be complex at the back, right? So intent-based networking basically expand on what I was talking about earlier on, right? Which is you provide the intent. The intent simply means what you want. What do you want the infrastructure to be? So you translate from the normal, easy to use language or however your user interface is into something that can be understood by the computer. And then it's activated means it's actually done. And then it will translate into the kind of either physical or virtual network infrastructure that you want. Now, the thing is there must be a feedback loop because you need to ensure whether your intent actually was translated correctly into the network infrastructure that you want. Right? That's where assurance comes in. Now, what I want you guys to see is that it actually transplanting the human with the AI. Okay, think about the infrastructure is the topology, the way you present, you configure the network is you as a network engineer. Imagine, Kelvin, you are given a set of requirement, right? The user asks you, you're a network engineer. So they said, oh, Kelvin, I need 3 subnets, yeah, and blah, 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 right? And then we go off, right? We said, oh, you need a switch, you need a router, you need etc., right? Then you come in, you design the topology, you connect everything up. Basically, that's what you're studying, networking, right? So look at this. This is a way to make your life easier. If you are asked to do enterprise, like 50 switches, maybe 10 routers, even then, right? So here, what they wanted is you have the intent means what is your idea, how you want the infrastructure to be, but in a language easier to say, right? Not technical, right? Technical means you have to go and plug in clean. That's very highly technical. Only network engineers, in fact, you know what? Cisco, no, they have to give you in fact, you have to go through your bachelor degree, 3 courses, right? In order to learn CCNA level. So translate to something because it's something like source code translate to object code or executable code. So here, translate the intent into something that the computer understands. And then it will be implemented under activation, it will be implemented into the network infrastructure that you intended. And then as a feedback loop to check whether the created infrastructure is actually what you wanted, right? It will be reported back to you, right? The user, and then you double check. If it's not, then the loop continue again. All this activation and these assurances are done by AI. That means artificial intelligence. Okay, smart software, right? So here you can see all the way it's implemented. So you have this Cisco digital network architecture called DNA, where the intent is here, and then obviously the intent-based network architecture has security and learning process for the smart computer, smart AI, right? All right, so I believe this is the future, but a lot of this is need to be invested into by the organization, right? So we saw the four, this is the fourth part, and each of the part actually prepare you guys that there's a lot of things that needs to be changed, right, in order for this to be there. But this is the future of network implementation, network maintenance, network creation, right? So the Cisco DNA assurance, this is the assurance, that's the feedback just now, right? So you can see machine learning improve network intelligence to predict problems before they occur. So if there's a problem, right, they will try to handle it. If not, they will report it up, right? There's a dashboard, okay? Dashboard for that means the network engineers or network administrator will have this dashboard to view what's happening with the network, right? Is the performance up to what they intended, right? Of course, we have security, okay? This is to enforce any security policy that the organization wants for their network, right? Right. So DNA, this is branding. Cisco DNA Center is a branding for their implementation of what they mentioned just now, right? So it's a network management and command center for provisioning and configuring network device. So imagine that it's a place, centralized place for you to look at the overall view of your network architecture, right? This is a very grand design for me, right? Because you can see inside your one dashboard, okay? Maybe you have multiple pages, multiple tabs, right? You can see here, you have design, policy. You can basically design your network. Now imagine, we go back to what I was talking about. Imagine your packet tracer is not just for learning, it is actually for real one, right? Of course, physical, virtual will be placed on physical. But how do you place virtual on physical? By having virtualization. That's why we started off with virtualization, right? And then if you think about it, you can virtualize, right? Operating system, you can virtualize network services. So it means you can then, if you imagine that it's a virtual network in any way, in any case, then why not? I can then direct how I want the virtual network to be. So this is the part, the design part. You can imagine an interface like your packet tracer where you can drag and drop and then create this and that, right? And then you have a policy tab where you can enforce policy, right? So this policy is basically you can then put in rules what your organization wants, right? And then you provide the to your users the provision. That means you can authorize who can access the network, all this, right? You got security. Then assurance is once you implement it, you want to see, you want to monitor. That is what SNMP provide you. But they say SNMP is not capable enough, right? So this assurance is a model that provides you very similar to what SNMP, but I think in a more robust way, right? Okay, so all right, so can you guys view the video on your own? Because it talks more about what I was briefly talking about, yeah. And that's the end. That's it. So I think it went rather good. It's like when you reach the end of the movie, you can see the future. So you started off with FCN. Let me tie it up for you. You start with FCN, computer networks, go to ACN. And it's all about you becoming a network professional to look after all the network, you design it, you troubleshoot, you configure it. You learn a lot of configuration commands, yeah, for iOS, and you end up with, okay, the future is SDN. That means software defined network, right? That means it's virtualized network, and you can use a lot of new tools and new technologies to actually to do it. So it's a little bit different from what you're doing right now. And if you're asking, why do we learn this if this is the thing that's coming in? Because although this thing is coming in, a lot of companies still use traditional networking. All right. So that ends our chapter, that ends our ACN, and that ends your CCNA course. This is actually, the whole thing is actually based on CCNA. All right. So within this week, okay, I will arrange a time with you guys, to share your quick feedback on your midterm test and also your SBA combination of your basically give feedback on both MTT and your SBA and also your coursework marks and whether you you're eligible or you did a good test or not. All right. So within this week, and also I will open up the net cap. This time I'm thinking I will give you guys at least 1 week time. Is that okay? 1 week time to do your net acad final exam, final chapter exam. If I give let me see whether it's a problem or not. Last time you guys joined the KL, how long did it for the fundamentals? No, so when you say longer, it's how long? If I give you guys 1 week, 1 week. No, this time I give you guys 1 week. It's okay. From maybe tomorrow until before the exam starts on other courses. Exam actually starts. I'm not sure. I haven't seen the timetable, but exam actually starts Friday next week, right? 29. Or exam. I don't know. I saw 29. How about 1 week? Oh, you guys need about what? 1 week? Why don't you finish your plan? Yeah. For the net acad, is multiple choice question. I think you do it for your part of your vision should be okay. Is it all right? Noel? Next week, starting from this week lah. This week, the net acad final exam. That means you have to do the course feedback first. Yeah, net acad, sorry. Yeah, the net acad lah. I will open for 1 week lah for you guys to go through and do. Yeah? Is that okay? Until next week. Yeah, until next week. So that means I'll give you 1 week rather than 1 weekend. Okay, better say can. Noel, okay?
Hi, okay. Noel.
All right. So,
good afternoon.
I will arrange with you guys when I want that means it's separate. I'm not going to wait until next week. Next week, maybe I will arrange a session for revision. Okay? So this week will be, I arrange a session for feedback. Okay, and if need to do network or not, right? Our feedback,
he's
the
not
MCC,
here.
and the
Okay,
SBA
so we wait for him first.
Your marks, and also
for you can continue.
And then next week, at least one session.
Are you already finished the practical?
We go through past year paper.
Questions number 3, practical 10.
Okay, Kelvin? Right? Yeah. Okay. All right. So I think that's it for today.
So please continue that.
We actually go beyond already.
Until Kelvin
your parents waiting for you.
arrive here lah.